All right, today we're going to talk about how much object-oriented design is enough. Basically, balancing design from the academic point of view, and that world versus the real world, reality and pragmatism. Because this sort of came to mind in looking at some applications that have been done, actually, particularly while looking through software patterns and looking at some of the examples that they provided and thinking about the real world examples I've run into that are similar, where in some cases, it's like, yeah, that makes a lot of sense. In other cases, it's like, no, that would be too much. That would be, as they say, over egging the custard, or that would be, buying the Cadillac when you just need a Kia, something like that. I think it's worth taking a look back at maybe some rules of thumb around object-oriented design. This really goes to, which is a nice little quote there that I stumbled across from Mel Brooks of all people. A lot of music is mathematics, it's balance. And this quote was actually really good, because if you think about music, and if you think about painting, and you think about the arts, there's a whole lot about balance that exists in any of those. If you have a piece of art that is just really doesn't feel right, a lot of times because there's not a balance to it. It's either, you can have like colors that clash, but you also have the same thing in music. You could have notes that don't feel like they follow each other properly. So, and it goes even to science, things like chemistry, you got to balance equations. Well, object-oriented design and programming, sort of the same thing. Really good design is an art form of itself. You have to find the right balance of preparing the code, of creating a solution that is maintainable and scalable, but also one that doesn't require you forever to get started and to implement. And of course, the extra challenge with these things is you've got these principles, these best practices that are part of object-oriented design programming. But then you also have these customers out there that have those pesky requirements. And sometimes those things conflict fairly heavily, particularly if you talk to a customer and you say, hey, if you offer them the idea that you can do the, in quotes, quick and dirty approach, there's more often than you would expect that you'll get an answer that says, oh yeah, just go ahead and do that. They don't really consider how valuable what's being done is to them. They don't understand what the risks and the impact of some of this kind of stuff. So those things can come into conflict. Another thing to think about is that really every decision that you make in designing software or just about anything, there is a cost to it. You may not think about it, it may not be immediately apparent, but there is going to be a cost, either immediately because of implementation time, or down the road because maybe it's not maintainable. Maybe it introduces bugs. Maybe it puts you in a situation where you're essentially designed into a corner. Anyone that tells you differently has not built an application for a customer. If there's somebody that tells you that you should just go 100% balls to the wall, object-oriented design every time, they're an academic. They have never really sat down and had to balance writing best practice, really good, solid code with, you have deadlines and resource constraints, budgets, and things like that. So the first question we want to look at is, why not everything in an object-oriented paradigm? Why not just design everything 100% object-oriented? Because we're going to assume that everybody sort of believes in object-oriented is a good way to go, and you get code reuse and all those other little magical buzzwords. Well, the first thing is the abstraction. Everywhere you abstract something, there's a cost in performance. This is why, even if you go to a base or a core language like, say, C is going to be faster than Java, because especially because compiled and things like that, there's not as many layers of abstraction from making the computer do the computations to the code that's written. But if you want to go faster than C, you can go down to assembly. You can go down to what basically C compiles into. So the further you get away from the source of actually doing, the more you abstract from it, the more layers that you have to work your way through to actually get to the data and manipulate it. Also, with object-oriented design, if you go nuts with your classes, you can make stuff very hard to understand and navigate for others, but also even for yourself. If you decide that every property of every class needs to also be part of a class and be instantiated, suddenly you can have all sorts of just nasty spaghetti logic that's really, it's just like just over and over instantiating classes, and you have to do this dozens or hundreds of times before you actually ever get to something that you can execute, where you have a method that you could actually call. Another thing with it is there's no need to abstract and create a general solution if you only have one problem, one specific problem that you're trying to solve. I run into this a lot with customers that have a very low budget, what they think is a very simple problem, and which sometimes is a very simple problem to solve. And a lot of the initial discussion is that they don't want bells and whistles. They don't want, a big solution. They don't want to spend a lot of money on it. They want, and they're saying really they want quick and dirty, but it's not really quick and dirty. It's just they want a direct solution. If you've got something where all your need is to, let's say, capture an address and a phone number and store it in a file, and that's it. It's going to pop up a little form, somebody enters their data, and it saves it. You don't need to go nuts with that. You don't have to have like a form class and a class for each of the fields that are being entered and a whole lot of stuff like that. You don't need it because it's not going anywhere except that, for that case, for that use. You see this in prototypes or proof of concepts. A lot of times those are good examples because you're essentially writing throwaway code, or you're writing it once and you're not really going to utilize it in the future. You can see this in data migrations. If you're migrating from, OS 2 to Mac, you're not going to do that more than once. You may have to call that application a bunch of different times on different machines, but for the most part, you're going to write that application once and you're probably never going to have to call it again. So there are definitely some cases where object-oriented design makes, not only is not going 100%, not only is that not a good choice, actually 0% in some cases may be the best choice. Maybe just go for a straight brute force coding solution sometimes happens to be the best. It'll be the fastest and run in the least amount of time. The last thing of this is with the to do object-oriented programming, you have to think a little bit more about design and about designing the implementation. Not necessarily design of the solution, but how the code underneath it is going to be designed. And although it's splitting hairs a little bit to split those two apart, there is some difference there. There are a lot of times that you can brute force your way into a solution and it works. It's just not very flexible, maybe not scalable, and it's going to be a pain to maintain. But if you only need to do it for that specific case, you don't need to worry really about maintenance or scalability or anything like that, then there's no reason to spend the extra time thinking your way through how would I do this again. Why do I need to solve for the general case if I don't really care about anything other than a specific or one or two specific cases? So object-oriented design and programming versus requirements. I talked about there's definitely some struggles there sometimes. The first thing you want to think about is when you're in this situation is the time frame. If the requirements tell you that you got to get something done quickly and you can get it done brute force quickly, and that's their primary concern. They say, you know what, we're not going to worry about doing it the right way. We're not going to worry about scalability right now. We're okay with the extra cost maybe that it's going to, that we're going to take on to potentially even rewrite this code in the future. But right now, we just need to get it done, for lack of a better term. Another thing to think about is, does the customer need a Cadillac, or do they just need like a Yugo or a Kia or something like that? I mean, do they just need a solution, or do they need one that is a high-end solution, or a really resilient solution? There's a lot of stuff that we know that we can pour into code that we don't necessarily need to. Yes, it's best, the code is going to be most likely to not have bugs if we do these things. That's why they're best practices. However, sometimes there's some corners that need to be cut, and there are a lot of valid arguments to cut those corners. Another thing is sort of, I guess it will pushes on the other side of that, is the long-term cost and maintenance considerations. When you're trying to figure out where this, where do the requirements and where does the object-oriented design, who wins, who gets the extra weight, and who do I need to side with in some of these situations. A lot of times, goes back to my earlier comment about customers, is they want to get this thing done because they need it done next week. But part of the discussion with them includes realizing this thing's going to be done next week, but it's also going to be used a year from now or 5 years from now or something like that. Well, if what you're building is a quick solution and it works with their budget and all that kind of stuff, but then in the long run it's going to kill them in maintenance costs, then that's where it's worth it to push back and say, if we take a little more time here and invest a little more time and money and do a good object-oriented design, then we're going to be able to save a lot of money in the long run. And I have been in exactly that situation where I had a customer that I had him for like 15 years, and I wrote him an application early on, and it worked, but there were some things that it was basically on a time constraints and budget constraints. And so I came back about a year later, and although I'd been maintaining it, doing stuff, I said, looking at the maintenance costs and what's going on, it would be worth it to do a rewrite and redesign and fix all of these things. And we repeated that cycle several times. Every time they said the cost to redo it was going to be too much. But over that period of time, they spent multiples of that amount of money on maintenance costs. And that's not including all the headaches of having to call me and schedule stuff up and getting deployments out and all the different things that were involved in that. So they would have been way, way ahead on time, money, and frustration if they had gone the proper design route. And I kept pushing them on it, but again, the last line there is, the customer is king. Customer, not necessarily they're always right, but when they make a decision, sometimes you got to go with it. So you can argue it. You can lay out some good reasons for proper object-oriented design of a particular solution or part of a solution, but you always want to keep in mind that if the customer pushes back, there's a certain point where they're going to either make a statement or push back enough that you should know that, okay, not worth fighting this battle, that we're going to go with requirements, and just keep it in your back pocket, one of those things. And then if they come back later and say, wow, this is becoming maintenance nightmare, you can say, you know what, here's an idea I had, and you just go dust off the one you had, pitch them again on properly. So this leads us to what are some good things to think about, and when does it make sense to push for object-oriented programming? And first one is long-term cost going to be high. That goes right back to that maintenance thing. If not doing it properly is going to turn around and cause a lot of costs down the road, a lot of development hours, maybe maintenance, just not the coding part, but just the understanding of what's going on part, the ramping up, maybe that's going to be very high. So that's maybe a good reason to say, we really need to design this thing properly. You need to think about the additional effort early on versus later rewrites, because there's a lot of times, again, where a customer will say, I just the budget right now. I don't want to take the time. I can't afford the time slip the slip in delivery time that's going to be involved in this. Well, sometimes you may not want to, but you sort of have to, because otherwise you may have to rewrite everything down the road. And that can be obviously a huge pain. And besides the fact that it takes all the code that you have written, and of course, if you rewrite it, then that means that you don't have the stability that already written, already tested, already used in a UAT and all of that goes with the code. That stuff now goes away when you rewrite it. And you can introduce new bugs. You may have old bugs that disappear, but usually you're going to see more new bugs than you are going to see a reduction in old bugs. One of the questions to ask a lot when you're really pushing object-oriented design and you're trying to figure out what's the best for the customer and help them understand, figure out if extension or additional features are going to be expected sometime down the road. Do they have a roadmap? Do they have a plan where you're just doing version 1, but they have a version 2 and 3 and 4 already that they're starting to think about and starting design? If you have a lot of additions, it's easy to see that this thing could turn into a big house of cards. Then that's where you want to make sure you get a better foundation, put a good object-oriented foundation on it so that you have something that's strong enough to put those extensions and additional features, and also to set up the hook so that you don't design yourself into a corner so that those things can be added. When you're discussing it with the customer, probably doesn't need to be said, but we'll say it anyways. It's just you want to stick to the business side of the arguments. The technical stuff of this is how all of the gurus do it or whatever, those kinds of things are not really going to help your customer. The things you want to focus on are the things that are going to matter to them, which are costs and maintenance and scalability and reliability and security. Kinds of things that they really, even if they're not a developer at all, they can understand and see why it's worth it to make that investment. Also, anytime that you find yourself arguing for doing an object-oriented approach, there should always be a why for it. The why should not be that's how everybody else did it, or that's how the code generator kicked it out, or something like that. There should be in your mind, in which you can also verbalize to them, a reason for why this approach or why designing this thing this way is going to be a benefit. So now moving to some key principles that you want to take advantage of object-oriented design. Deciding, when you decide that you are going to move forward with it, when it makes sense to do so, and some of the things that are arguments for taking this route. Of course, first one is, if you've got something where you're repeating code over and over again throughout the application, you can abstract that out into an object. And from a maintenance point of view, from a debugging point of view, stability of the application, if you've got code all over the place that is essentially the same, then it's a nightmare. Because what's going to end up happening is if there's a bug in there or if there's something that needs to be changed, then it has to be changed everywhere. And if you miss an instance and don't change it properly, then things get out of sync and it gets really bad really fast. And there are a lot of cases that I've been experienced over the years where there was code repeated in different places, throughout the application, and that stuff kicked our butts all over the place. It was just such a pain to get everything in sync that I think maybe every time, and if not just about every time, we ended up getting to a point where we said, okay, we've been bandaging this too long. We need to put together an actual project or sprint or something like that where we're going to strip all of that crap out, put it in one place and make calls to it and fix it. And that's usually what, that's what ended up happening. And we were able to move on from those issues. Large lines of code in a method or a function. If you've got something that's got hundreds and thousands of lines of code in a single method or a single function, another great place that just object-oriented, yes, you may have to put together a little bit of a structure and have some class names and some methods and things like that, but they're going to be easier to read and easier to understand and easier to parse during debugging than walking through thousands of lines of code. In particular, if you've got something where you've got a lot of like a switch statement or ifs or things like that, where you've got all of this stuff that's all these different parentheses and brackets, and then somebody reading it's got to figure out some way to like balance all the parentheses and brackets. And to me, it's nightmares of back in the day where we had the dot matrix printers, and we would print just like reams of paper and get in a big room and lay that stuff down and start connecting the parentheses to try to figure out how that stuff worked. If you can pull those blocks of code out, it's a huge maintenance and even stability kind of benefit, because you're going to make it something that's a little easier to understand. And instead of eating the elephant in one bite, in doing so and breaking this up, it allows you to do it in something that's much. A lot of times security needs are going to point you to object-oriented design, and you need to make sure that that's part of what you do, that there's the ability to encapsulate data and do some of those kinds of things that even within the application, it's going to allow you to, maybe in a little easier way to not pass around data that you don't want to pass around. Framework usage is a huge arguments on both sides of object-oriented design. Sometimes you end up in a situation where the framework basically or directly requires you to do object-oriented programming in a certain approach. There's some ways that you can maybe hide it, but generally speaking, you have to have at least an object layer on top of whatever it is they use. For example, Hibernate, it has an object-oriented layer of stuff that it generates. And honestly, that's part of the way it works, and how it's implemented has been part of the reason that I have ignored Hibernate in the past in some projects, because it just didn't fit our needs. Would have loved to have it, would have been a nice way to quickly be able to generate a bunch of stuff, but it was just too fat and heavy, and so we had to punt on it. But you will find that with various frameworks. And of course, some languages, if you're using Smalltalk or some languages like that, you have no choice. So there may be environmental issues that push heavily to say, you know what, we've got to do it, and if we're doing it halfway, we might as well do it correctly. We might as well do it the right way. We might as well actually design for this instead of just code to where the framework forces us to code, and then otherwise just again brute force our way through it. Another thing to think about is just development standards in general. Yours or the teams, there are some things there that often will point to, we need to have good object-oriented code, because we're writing a lot of different applications, and that allows us to move from application to application, developer to developer, and they still understand things. It's not a case where you're on one application and you move to another and it's a whole different beast. And there's like a ramp up time every time you switch from application. So that may be a good reason, again, and something definitely to consider as you are going down that object-oriented route. Quick and dirty, I've mentioned a couple times. As I mentioned, a lot of times it is a customer choice if you're dealing with small or mid-sized customers. Now, if you're working at IBM or Microsoft or somebody like that, they're not going to go that route. They're going to have thousands of developers and Six Sigma consultants and black belts and all that kind of stuff, and they're going to quick and dirty is not. They don't even get near that. They're going to do it long and drawn out and as painful as possible. Not that it's necessarily painful. But counsel against this, the whole quick and dirty thing, if you're going to counsel against it, in a lot of cases, there is a reason to do so, and it's really going to be based on risk. Is look at what they want generated. Look at their why. What is the problem they want to solve? What is the situation around that problem and the users of that application when it gets done? And if you go quick and dirty, if you skip some of the good object-oriented design principles as part of creating a solution, is that going to cause them more headaches than it's worth? Is there going to be a lot of risk there as far as things like scalability and reliability that they really do need, but maybe they're just not thinking about it right now because they just want the solution. They're not thinking about, well, what if I create a solution that blows up every third time somebody uses it? So there's some good arguments there where you'd say, let's slow it down. Let's go with an object-oriented design, because then we've got something that is easier to maintain, is easier to fix and to analyze. And that goes into that research and understand the risk that's involved. It's not just that there's a risk, but is this a risk that it makes sense for them to take or not? If the risk is scalability, but looking at their reality, they're not going to have to scale this up. They're not going to have more than a few users for the first year. Then the risk doesn't, the risk is essentially mitigated at that point, because they don't really care. It's like, we'll deal with that a year from now when there are some more users. And by then maybe we've got a budget to be able to fix this. When in doubt, there's always opportunity to put some design in that leaves you some hooks, or at least some ability to refactor later on. What you want to avoid is total rewrites. Refactoring, obviously, you'd like to minimize the amount of times you deal with that, because every time you refactor, then there's potential for introducing new bugs and all that kind of stuff. Of course, total rewrites are exactly that. There's a lot of risk involved there. So if you're looking at a solution where lack of design, going through and doing that full in a China shop brute force approach would potentially have you in a situation where you'd have to completely rewrite this thing soon down the road. That's something you definitely want to bring up to your customer and help them to understand. And of course, there's security and compliance issues. Depending on what you're building, much like frameworks, if you pick a certain environment like Smalltalk, or if you're working with certain IDEs and things like that, they are going to be easier to use, and they are going to sort of steer you towards an object-oriented approach. There's some security and compliance things out there that are the same kind of way. If you're having to build something for HIPAA compliance or PCI compliance or any of those, since there are changes in those compliances every 6 months or a year, then there's some things there where it's going to make sense to plug in maybe certain features or leave hooks for certain features, because, for example, user account access and logins and passwords, those security rules that come out of these compliance types change from time to time. So if you just again, brute force your solution, then maybe the next time these things change, suddenly, like for example, passwords, maybe you go through and you just say, oh, well, we can just make the password say up to 20 characters everywhere and we're fine, no problem. Well, what happens next year when they say, okay, to be HIPAA compliant, every password has to be a minimum of 40 characters in length and have these 8 different attributes to it? Well, if you just hard-coded your way in it, you're going to have to go rewrite all of that stuff. So always something to consider there is look at the entire picture of what their solution is, because sometimes it's not just what the customer requires, it's going to be what their business or their industry requires. Calculating the cost. When you're talking to a customer, or when you're thinking about it yourself, is think about what is it we're really doing here? Are these things that we're designing, are they common features? Are these things that are going to be used over and over again in the solution? Are these like one-offs? Is it, for example, a lot of times you get a solution, it doesn't really matter what the problem is, but you get a solution that has the ability to save preferences off to a file, or generate an email report of some sort that's just just sort of like a usage report or something that's not anything. It's just like a nice to have. It's just something that you add on because it's easy enough to do and it's a convenience thing. But it's only going to be used once in a blue moon by the users. That would be essentially a one-off. You could design it nicely and go through all the object-oriented design stuff and follow all those principles, but if it's not being used that often, then not the value of doing all that extra design is not going to pay off. Basically, you've done all this work and it's just not used enough. Versus things that they use on like the first screen they see on their home screen, and functions that are particularly like the primary function, the primary why of that application. Those kind of common features are the ones that it makes a lot of sense to design those properly. Or things that are common features across the application that are used all over the place. So a great example would be an application is highly graphical. It's got a lot of forms. Maybe it makes and it probably makes sense to have an object-oriented design to the form controls, so that you can do things like adjust sizes and change the data entry types and masks and stuff like that, which is what you see. I mean, they're not always, a lot of times they're more like object templates than they are actually object oriented, but a lot of times you'll see at least an object oriented to some level where there's at least a common interface across all of those. So behind the scenes, you can work with a whole lot of different types of controls without having to write a whole special handling for each of those different types of. Another thing is that you're going to get, anytime that you're using things over and over again, there's going to be an increase in quality by doing it. Initially, yeah, you're probably going to, you may see some bugs in it because you're going to hit that code regularly, often. And if there's any bugs, you're going to exercise it and those are going to show up. But then once you fix them, you're good. And of course, using it early on, you get the bugs figured out. And then later on, you know that, oh, I can use this thing and it's bug free because we've used it 1,000 times and we've nailed all of the bugs. We've squashed all of those. Huge consideration is testing. I think this is one of the most overlooked reasons for and against things like rewrites and refactoring. What is the impact of a change? Now, in an object-oriented code, yes, you could have a single object that is, because you need to change it and you need to change it for this one little area of the application, but it's used everywhere, then yes, it could impact the entire application. So maybe that is going to require you to retest the whole application. But maybe not. Maybe it's one of those that instead, because you've got an entire application and you see this one little bug and you know that this thing is popped up all over the place, that because it's being reused, you fix the one bug in one place, and yeah, you can spot check a couple others, but generally speaking, you know that it's going to be fixed everywhere if it's fixed. I don't know that it's overlooked, but I think just in general, our estimation skills are always a little bit lax. And the cost of doing object-oriented design seems to be not always understood. So you need to really think through what it is that you're building and the time required to actually create a general solution to whatever it is that you're trying to solve. Because there's a lot of times that we look at stuff, we say, oh yeah, this is pretty easy. All I have to do is throw these couple, 2 or 3 parameters in, and boom, now I've got a general solution for this. And then we find that it's not, because there's outliers or special cases that we need to deal with. So got to factor that in as far as calculating your cost of going with an object-oriented. And really the concept that comes up over and over again in these discussions is a pay now versus a pay later approach. You're either going to spend some more time and effort now designing it properly and doing what you need to do correctly, or you may have to pay later because now you've got something that doesn't scale, or maybe it's not very, not very useful, or maybe it's got a lot of bugs in it. All of the maintenance could just be, maybe it takes so much time and it's so fragile that the maintenance is ridiculous. Or you have bugs that get fixed and then they rear their ugly head again because of all the different copies of the same thing. One of the things that's definitely I think a primary part of that discussion when you're calculating costs is really focus on what is it that we can afford essentially to put into it now, and what is it that we're just going to have to push those costs off. So when we're going into doing the design, here's some things, this is sort of talked about whether you do or not, but I think it's a good point now to discuss what is it, what are some things that you need to think about when assuming that you are going to take an object-oriented. Well, the first thing is this something that's going to change? Do I need, and really now we're focusing on the abstraction side of it. Am I going to abstract this solution, this code, out into an object-oriented solution? Well, if this is code that is never going to be touched again, then you probably don't need to. It goes back to the quick and dirty or the direct approach works fine. There's no need to abstract it out. But if you do, how many levels of abstraction really make sense? We can find this really has a good analogy on the database side when you talk about normalization. Is there's first, second, third, fourth, fifth, sixth. I think there's a seventh normalized form, which basically gets to the point where if you've got it like ultra normalized, then you don't even have the same text repeated anywhere within your database, which is awesome for size. It can have this huge database and have it be not terribly big, but the processing time is just insane. You end up having 15 table joins and nothing runs well. So object-oriented design, you run in the same thing. Is you could have an interface, and underneath it's got a class that has like a couple layers of children, and then the next thing you know, you're 8 layers deep on a hierarchy, and stuff just doesn't handle that very well. That's going to have a cost to it. Many years ago, I worked in a tool, actually early on in my career, I worked with a tool called Power Builder. And it was an object-oriented programming tool. And it had its own object framework. So anything that you built was built on top of that framework. Well, the company I worked for, we built an object-oriented framework on top of their object-oriented framework to make it easier to use. We took a lot of common tasks and we built those as, we extended, which is what you can do with this stuff. We extended it with another layer of objects. Well, we took this stuff that we did and we sold this as a tool to other developers. And so they would come in and they would build their stuff on top of ours, and usually a couple layers of it. Well, by the time you were done, it was not uncommon to be 6 or 7 layers deep in an object hierarchy. Thing is, the tool did not handle that very well. Once you started getting beyond, I think we figured out once you got past a third level of abstraction, of hierarchy in an object, it started having issues figuring out like relationships and things like that. So when it was compiling stuff, it would break links and it had all kinds of issues. But you'll see that with other stuff, is that you'll see even now, the code it's progressed enough that most of these the modern languages can handle some pretty deep hierarchies. But you will occasionally still bounce into stuff where it's just so slow to like create an object, because it's having to go out and find the root, and then find the parent, and then find the other parent, and then find the other parent, and then you can have all of these layers of stuff that's going on beneath under the covers of all of these constructors and all of the things they're doing. The next thing you know, it can take forever for stuff to get built. Hibernate was again a perfect example of that, because what it would do in some cases is it would not do lazy loading. So if you had an object that was a record in a database that linked to other tables, then it would create that object for the first record, but then all of those little other table records that it linked out to, then those things would get created. And if those linked, then those would get created. So if you had a really complex relational model, you would just blow that up. It would not work. It would be so slow and painful that you would be sure that you had bugs. And it was just taking that long to get going. So make sure that you're not overdoing it, that what you're doing every time you're abstracting, that there is a reason for that. So not only is there need to be a reason why you're going with an object-oriented design, but also why you're taking it to the next level. Think about closed versus open code. If you're building an API or something that other people are going to build on top of, essentially open code to some extent. There's other people who are going to be using it. These are people that need to understand enough about how your code works, if nothing else, even as a black box, to understand what do I put in and what am I going to expect that comes out. Versus closed code, where it's stuff that is completely a black box. Anything that's within that box, other than so that all they need to know is what do they put in and what comes out. Anything that goes on within that box that doesn't impact them, then you can do that however you want. So if it's something that they're seeing, it's probably going to be easier and make more sense for it to be an object-oriented approach because people do understand it. It's easier to have well-defined interfaces, contracts, and things like that, versus if it's a closed system, then it doesn't matter as much. Now, all the things like scalability and maintainability and all that, it still matters, but it matters more if you're going to have other people, if you're going to have third parties or other developers come in and deal with the code behind it. This goes back to an earlier comment. Basically, sometimes tool integration and code generators are basically going to force you to a certain level. Again, Hibernate, although it feels like I'm picking on it, it's another good example. Is it generates a layer of stuff that you can go in because you have the source. You could go in and you can modify those classes directly. But ideally, what you're supposed to do is abstract a layer so that you don't have to go in and directly modify the generated code. Because, of course, when you regenerate it, that would break all of your changes. So you need to have that level of abstraction so that you can regenerate code and still have everything work. So depending on the tool or the environment that you're working with, sometimes abstraction is essentially a must. Otherwise, you end up in a situation where you're essentially writing somebody else's code, and as soon as they get an upgrade or fix release or something like that, now you're unsupported or you're broken, or you have to find a way to move their changes into your changes, and it becomes really bad really fast. And of course, we go back to your coding standards. Your teams, your development standards may have a way that you just generally will have a certain layer of abstraction that you're always, maybe you always say, let's always keep a layer, a base layer of objects for our data that has an ID and creation timestamp, some properties like that. No matter where we're at, we want to always have that abstraction because we need that. That way we know that everything that we build has that interface and everything gets to work off of that. Okay, that makes sense. That may be something that you want to consider as part of your decision to abstract it. The inheritance side of stuff, a little different from abstraction, is one, think about whether you need an interface or whether you really need to inherit stuff. This comes up again a lot when you look at software patterns. There is a way to essentially do the same thing through inheritance and through an interface. There's a lot of different things that are available that way, where you both of them are essentially building a contract of sorts. The thing is, if you've got an interface, then you're not necessarily going to have it. You're probably not going to have any functionality up at the root level, versus inheritance, you very well might. So in thinking about that and thinking about your inheritance in general, you need to think about where would the functionality be implemented. If I've got a parent and a child and a grandchild, where does it make sense that I would maybe have implementation of a function on each of those levels? Or there's certain things that it makes sense that I need to have a parent that does that, but then the child class has this other functionality or this additional function. And that may be the whole reason why I want to do it, is I want to inherit and extend, is I want the child to have everything the parent has, but they're going to go out, and really the difference between the two is just the child functionality that does not exist in the parent. For all of the child functionality that exists in the parent, it just uses the parents. Something like that, and then inheritance makes a whole lot of sense. But if it's really just a little bit different from, like let's say it's a R type, and one is got one is a race car and another one is a street car, and they've got some different things that they do. One go can drift, and the other one has like just braking functionality. Maybe one's four-wheel drive, one's that kind of stuff. Then it may make sense to have a base class or a base interface in that case that is things like being able to drive it or run it or stop it. That, but then you're going to have all of these. You're going to have a lot of other functionality. You're basically have them implement the same, but it's not. There's not like a generic car that would make sense that you could have. When you think about it, I guess the easiest way to think about it is if the core or the root class is something that I would implement by that it makes sense on its own, then let's go ahead and make it a class. Otherwise, it's an interface. If you think of lists in Java, that's a good example because they don't have the idea. There's no actual list. There's an implementation of lists. So there's a list interface, but there's a thing like array lists and stuff like that those are the actual implementations of it. There is not a generic implementation that would make sense. When you're thinking about interfaces versus inheritance as well, there's the idea of properties versus preferences. It may be that class has properties and it has things that it needs to have that are part of that make that instance. Things like sizes and colors and stuff like that. Well, maybe it's not really so much there's attributes, but they're preferences. So that you could have an interface where it just checks a couple of values here and there, and the classes aren't different. They're just essentially working with slightly different data. For example, that would be an output kind of thing. If you've got something that's outputting a string, the fact that it outputs the string red, blue, and black you're not going to have like a red, a black, and a blue property. It doesn't. You don't have to have a red class, a black, blue class. Another thing with inheritance is whether this is core functionality or not. If this is something that's used a lot, and you're going to see that you see extensions of that make sense, even either in the current solution or coming down the road. A good example we've used in the past would be things like a database connection. If your database connection is always going to be MySQL, then you're not going to have to worry about inheritance or anything like that. But if part of your core functionality is that this thing is going to be compatible with 5 different database types and maybe more in the future, then you're going to want to make sure that you have it. You have stuff. You've got an inheritance of some sort built into your solution. And the 80-20 rule there applies, where it's basically if you can get 80% of you can get 80% of your functionality covered without getting into inheritance, then maybe you don't need to worry about it. Because otherwise, you don't want to spend all that time. You don't want to spend 80% of your time working on that little 20%. Something that's used a lot. Let's go ahead and go with the polymorphism. Thinking about that, a single application versus a framework. If you've got something that's just a very simple application that doesn't have a whole lot of functionality, a lot of methods, then you probably aren't going to have to worry about polymorphism. If you've got a framework where you've got a whole lot of different types of objects out there, you got a lot of different pages or data structures or things like that, but they have to have a commonality across them as well, and they have to have a, lack of a better term, like an API, so that if I'm working on widget type object and I have a print, I want to also have a print on the gadget object. I don't want to have to, in one case it's a print, in another case it's output, or write or something like that. So sometimes, it's convenience for the developers, but it also makes it easier. Related to that is this an individual, is it just you writing code, or is this something where there's a development team? So it really makes sense to have that consistency that polymorphism can bring? Are there coding standards? Is this just something that part of your coding standards that you want to make it generally that we're going to have, we're going to limit the numbers of method type names that we have, and we're going to work, we're going to allow them to have different parameters so that we can use the same thing. And then it just becomes a matter of saying, okay, I know this thing exists on this class. I said, figure out what the parameters are for it. Sometimes that's a little bit easier than trying to figure out what the heck is this thing called. Again, it goes back to your application size and complexity. If you've just got one or two classes and 100 lines a piece or something like that, then you don't need to worry about it. You just go out and do what you do. And now, granted, that means it won't scale. If you come back later and add 15 more classes, then there's going to have to be some refactoring, or it's just going to look like 2 or 3 different people wrote the code. But if it's something that's huge and complex, the more that you can essentially get some standards and naming and things like that, Morphism helps bring to the table, then do so. And as always, each time that you take a look at something like that, take a look at the value or the return on investment for it. Is this a method that makes sense all over the place, that should do it in a polymorphic way, or does it make more sense that I'm going to have completely different names for it that are just descriptive names for it, and they're not going to reuse code anyway? Common mistakes that we've covered some of these already, but one of the common mistakes I find, especially with call them newbies or even evangelists to some point, is assuming that going the all object-oriented approach is always the best. Early on in my career, there was a lot of arguments and discussions and things about this, about what is really object-oriented and what is not, in doing it the quote right way. There's trade-offs where a lot of times you can find reasons to break the rules. Sometimes the rules are meant to be broken, and sometimes with software, that's the thing that you got to remember, is that yes, this may not be the best approach in general, but in this case, it does happen to be something that makes a lot. And we find this sometimes all the way down to the famous kinds of comments that you'll find where the comment says, I'm doing this thing here because it makes stuff work, but I have no idea why it does. So don't delete it, don't change it, don't move it. If you've been around coding long enough, you've probably run into those situations. We have the same thing here. There's times where you may look at it and you say, you know what, the object-oriented design approach is just too fat, too heavy, too confusing, too difficult, whatever it happens to be. And I think I'm going to go a different route. A lot of times, we mentioned this earlier, but I do want to hit it again because I see it a lot. It's fair to consider the risk and test implications of changing the design. Either moving to object-oriented design with something that needs to be refactored, or not going the object-oriented design, going the direct route, the short and simple route. Going in and changing that later may have very far-reaching implications as far as what needs to be tested and how thoroughly it needs to be tested, and what the risks are for that code to, what happens if that code doesn't work, or if that code, if we've got some bugs somewhere there, how hard is it going to be to maintain, fix it, or debug it in general? Related to that is we tend to be short-sighted about the impact of these kinds of changes. We go in and we say, we don't really have to do it right. We don't really have to go the object-oriented design approach. But then you find 3 months or 6 months down the road that you really should have. We think too often, I think, that we don't remember that this code could be around for a long. We may not be the next developer that touches it. We may leave this job or get hit by a bus or go on to something else or whatever, and somebody else has to come in behind us. That can be sometimes very not fun. So doing it right, we do need to value that impact properly. Another issue, we assume stuff's dynamic when it's not, or we assume it's static when it's not. This is where a lot of times in conversations with a customer, I'll be sort of belligerent a little bit about stuff and say, in this situation, is this always going to be the case? And they'll say, oh, yeah, that's always going to be the case. No, always. I mean, these parameters or this situation, that will always be the case. There is no situation where that will be different. For example, we see this a lot with security. Is it the case that no user will ever need to see this screen unless they're administrator? And they'll say, oh, yeah. And then somewhere down the road, oh, well, report writers need to see that screen, or certain managers need to see that screen, something like that. That is designing into a corner. If you haven't really and fully thought out whether this is a static solution or a dynamic one, where there are going to be changes to the requirements, essentially, then you can end up in a bad situation. So, and that's one of those, when in doubt, you obviously want to leave those hooks or some ability to make those changes. Final thoughts. Do not assume that all object-oriented programming is the same. Just because Bob down the street said, oh, yeah, we're doing object-oriented programming and we've got the solution, it may be very different. The impact, the way they do it, the level to which they do it, the designers, because it's art, in a way, there's an art to it. It is personalized every time, either to an individual that's an architect or designer, or to the team, which is probably more often the case. When in doubt, as always, it's best from an object-oriented design, moderation where needed, is find a way to respect the object-oriented design principles and to do things in a way that makes sense for that application, but you don't have to go all in. You can create an object layer without having to create 3 object layers, things like that. Always be considering whether you're talking about static or dynamic requirements, because that should always be part of your why, part of your argument, is whether I can let this go because it's static and I can get this thing done once, and if it works, then it works forever, or it's dynamic and yeah, it may work today, but tomorrow when we make this change, or when we add these new types of users, or we go to this different platform or extend to this different area, suddenly requirements are changed and maybe this won't work anymore. And that brings us to everybody's favorite question and comment portion of the discussion. So I'll open it up now for any questions or comments.
Sorry, I had to wait for audio to be paused. This is really good. Some of the questions I have, though, so I know you picked on Hibernate quite a bit, but one of the things back in the day, and I still see it come up every now and then, is you can run into cases where people still use struts, or they use JPA or JFS on the Java side of things, where they embrace an object-oriented framework, but they don't employ it. Like you said, where they have classes which have thousands of lines of code and they don't abstract it correctly. Case in point, we have this one application that we still support. We keep selling it. It's not the money maker. It's written in JFS, but there's 20 bugs I've identified that they won't fix because they're afraid they're going to introduce other bugs, and the impact or the usage of the current bug is maybe 1%.
That's a good point, and probably almost a presentation itself. Yeah, I didn't even stumble across the people that halfway do object-oriented, but not really, and can that's one of those where it's part of, I think, programming standards, development standards and things like that. Understanding how to use what you have. I really didn't get into. I mean, this presentation, I sort of went with the assumption that you or your team understand object-oriented design and how to do it and what makes sense. But yeah, there are some more than a few situations out there where the environment points you to it, but the people that implement it still implemented it in a functional way. Like Hibernate, I've seen that a lot, where they go right in and they start directly changing the code. I've seen struts where they did that. They're do it right. Yeah, it's definitely going to be oriented. It's going to have the pluses and minuses. If you do it halfway, and this is, I guess, where there is a difference between moderation and doing it halfway. Moderation is doing it right, but you're not necessarily taking it halfway. Is you sort of start with what you're given and then wander off in a different direction. You don't want it to. Again, it's like you don't want to have two different approaches within your code. If you're going to have an object approach, then it should be well thought out and have well-defined limits that make sense to how deeply object versus just not understanding it. And a tool gives you something that's object-oriented, but then you just say, screw it, I don't really care about that. I'm just going to code it whatever is comfortable. That's a great point to bring up.
Yeah, and to your example, so the situation I walked into where, I've been a manager, I've been a developer, I've been senior developer, I've been an architect, and I took this QA role because they were not necessarily doing test-driven development, but trying to build a test framework using Selenium with Java. And I walked into an already existing kind of object-like framework that had a lot of not necessarily deadlock, but you had there wasn't a level of abstraction. Everything was connected, or I'm missing the word for it, but there was a lot of circular dependencies on things that didn't need to have dependencies. They needed to be standalone. The level of abstraction was not at the highest level. So basically, you had multiple tests for multiple different agencies that had different scenarios tied directly to the actual action, where the action should have been independent. So I built the framework I went with was completely a hybrid of data-driven development meets page object development, where you abstract it out at the page level. You define your elements, you define your actions, you define your assertions at the page side. So that's at the application level. Then at the test level, you have your test framework, you have your test abstractions, you have your test layers. So I took something that was pre-existing and I took it to the correct layer, pulled out all the abstractions, all the coupling that was going on, and made it a true abstract object-oriented framework. And then I decided to take that one step further and build a code generator that will basically build the framework for you.
That's a real good example of someone not thinking far enough ahead. Potentially. I mean, I guess there could be something where they just didn't have the budget or something like that, and they just said, well, maybe they went into it knowing that was not the best solution, but that was what they had to do. But that's the cost, is then that you had to come back in, behind them and abstract it properly and deep couple, or do the proper coupling and decoupling to make sure that the solution space matched what it was trying to do, as opposed to a bunch of hardwired stuff.
Exactly, and it took us months to figure that out, because we went through 2 or 3 releases where I would complain that a test was broken, or a particular flow was broken, only to find out that a fix we did the previous sprint broke that test. So I fixed that one, and then the next time I ran, I broke the previous test. So we went back and forth for a while till we finally figured that out. So those are things that you will encounter or potentially can run into in a poorly designed OOP approach.
Yeah, that's what I refer to. The resurfacing bugs is a common side effect of that. If you don't do it right, you go fix it in one place and it breaks somewhere else. And you fix that and that breaks something else. Or you find that something you thought you had squashed it everywhere, but you hadn't. There's actually other cases where that is used or where that rears its ugly head, and you thought it was fixed, completely fixed.
Now, one thing in the Java realm, or I should say in the Spring realm, that you should be careful of with object-oriented, even though it is pretty strict on what you can and cannot do, is Spring Batch, because you can so go off the reservations with the object-oriented approach there, and you can so brute force it to the point that, yes, it works, but it will only work in your one instance.
Yeah, that's that's typically what you'll run into. That's the quick and dirty kind of thing, that you end up essentially designing yourself into a corner. Because what you've done is, yeah, you've solved it for that one problem, that one configuration. But as soon as you move to a different one, suddenly things start to break. Yeah, and Spring Batch is when I've run into that it can be, you're not thinking about it right. Found a couple of, I didn't really think through it exactly, or didn't realize really what the steps were that needed to be laid out, and like, oops, got to rewrite this thing or break this out in order to make it. Always have in mind as you're doing this stuff. Other questions or comments? So what have we learned today? Well, object-oriented design is not a black and white endeavor. It is definitely, there's an art to it, probably some science as well. Actually, there's definitely some science to it as well, but there is it's not an all or nothing. It's not something where you can just like paint it and say, oh, yep, there you go. I've used object-oriented design and I've used it exactly right, because it's not a solution. As importantly at least, decisions have a price. Whether you abstract stuff or not, whether you make an interface or not, inherit or not, however you do it, there's a price. Either pay now or pay later. You want to make sure you measure the ROI so that you're doing an application that you don't regret doing somewhere, or you don't make someone else regret that you did it somewhere down the road. The last thing I do want to mention, you don't score points for good design and failing to meet requirements. That is a rookie mistake, if there ever was one, is that somebody comes in and they're a developer and they understand academically how all this should work, but in doing so, it doesn't meet their customer's requirement. There's something about it that, either, which could be as simple as it doesn't make the budget, or it's bigger or slower or more ponderous or whatever than they expect. There's a lot of different things that, a lot of things that could go wrong, that you can sit there and you spend a lot of time designing and design a really awesome solution. But if your awesome solution isn't a solution to their problem, then it's a failure. As always, thanks for your time. Plenty of places to contact us if you have any questions, if you have any comments, if you have any suggestions. As always, got the email address out at info@developerpreneur.com. Hit us on our contact form. @developerpreneur on Twitter. We have a lot of stuff coming through there. There's a lot of articles. Particularly lately, there's been a lot of stuff on software patterns and object-oriented design and architecting software. So a lot of good stuff there to just check out, even if you can share with us. Also, we've got the Developerpreneur Facebook page, trying to put a little more content out there on a regular basis as well. As always, so we can make every developer a little better, and we're making ourselves better along the way. So have a good one.